Welcome, everyone. Good evening. This is the second of the 2018 Science for Alaska Lecture Series. I'm Sue Mitchell. I'm the Public Information Manager for the Geophysical Institute at the University of Alaska Fairbanks. Our lecture series is sponsored by the Geophysical Institute and the Alaska EPSCoR program, and it's brought to you by a generous donation from the Triplehorn family, as well as this year from the Lifewater Engineering Company and Class 5 Boatworks. Thank you very much for your donations. Now, I'd like to announce tonight's speaker. Rick Thoman grew up in the Amish country of Pennsylvania, and he dreamt of life in Alaska. He's worked in the weather and climate business for the past 35 years in both public and private sectors. He realized his childhood dream when he joined the National Weather Service Alaska region in 1988, and after 30 years he is now comfortable calling himself an Alaskan. He currently works as the National Weather Service Alaska Region Climate Science and Services Manager, and he's the author or co-author on a dozen or more papers on aspects of Alaska climate and climate variability, including basic climate analysis, wildfires, and marine heat waves. He has a Bachelor of Science in Meteorology from Penn State, and I was interested to find this out, a Master's in Athabascan Linguistics from UAF. He's also says he's working on a PhD, but that'll be sort of a retirement project for him. His pastimes over the year have included dog mushing, hosting a medieval music show on KUAC, and being the historian for the Thoman family clan. So welcome, Rick Thoman.
All right, hopefully you can hear me now. All right, well, thank you very much. Boy, what an honor to be here. Quite an august gathering of Fairbanksans here, so I'm very humbled. And thanks to Sue and Fritz for inviting me and making this happen. So as Sue said, I work these days as a Climate Science and Services Manager for Weather Service Alaska region. And you might be wondering what a Climate Science and Services Manager does. Well, I have a couple main parts of my job, or at least a couple of the most interesting parts. I spend a fair bit of time putting current weather events into historical context. So I've had several inquiries. How unusual is this? Today was the 15th day in a row of 20 below or lower in Fairbanks. How unusual is that? Let's say a big storm is forecast in the Bering Sea. When was the last time we had a storm like that? So that's one part of my job, and maybe what you might think of as climate. The other part in the Weather Service, climate means any forecast beyond 1 week from now. So I have all of the past and all of the future except for 1 week. So I've got most of the timeline in my job description. Tonight we're going to be mostly talking about the past part. So I'm going to start out talking about the people behind weather and climate data in Alaska. Give you a little bit of a history of Alaska weather and climate observations, where and how they've been taken, and then just illustrate some uses of what we can do when we have decades worth of high quality data. And of course, since we're all Fairbanksans and it's winter, we're going to focus on interior stuff and the winter and a few other odds and ends as well. So hopefully you find this enjoyable. So if you thought you were coming to a presentation with lots of charts and graphs and maps, you're at the right place. But we're not going to start out there. We're going to start out with tipping our hat to the thousands and thousands of people over the last 5 generations that have taken the time, sometimes paid, sometimes volunteer, to gather and collect these weather and climate observations that make up really our priceless heritage. I mean, If all of a sudden tomorrow the president decided that climate research needed $1 trillion, that'd be great. But you know what we can't get? No amount of money can get us that old data that we don't have. No amount of money. So we have people like Melvin Summers, one of the very first meteorologists with the Weather Bureau in Juneau, who wrote the first data-driven climate analysis of Alaska. We had hundreds of men and women during World War II taking observations all around the territory of Alaska. We had people like Corinne Gagou here, who was with the Weather Bureau in Fairbanks here in the 50s and early 60s. I do hope that she dressed up for the Newsminer photograph here, launching the weather balloon in a dress and high heels. I hope she wasn't doing that in July or in January. We have people like Ted Fathauer. Many of you will remember Ted. Not only was he the head of the Weather Service Forecast Office here for almost 20 years, but he gathered weather data at his home on Chena Ridge that are fundamental to understanding what goes on with our inversion that's so important here in Alaska. And then there's people like on the bottom there holding the big plaque, John Borg. The cooperative observer in Eagle. He's been, just because he's interested, he's been taking daily weather and climate observations every day for more than 40 years now. And here he is getting the very prestigious Thomas Jefferson Award. It's people like this, since the 1800s, that really allow me to give this presentation. So, brief history. Well, let's start out, of course, with the non-Western weather and climate information. Of course, traditional knowledge for thousands of years. People living traditional lifestyles in Alaska, of course, have an innate, deep understanding of weather, climate, not just the averages, but how those things can be expected to vary. Every season, of course, can be different. And of course, that's not unique to Alaska. All traditional societies, whether Athabascans in interior Alaska or my ancestors, subsistence farmers on the Rhine River Valley in Europe, intimate knowledge of weather and climate. So we'll jump ahead now to kind of the Western society view. There actually were weather observations gathered at Sitka during the Russian era from the 1820s until 1867. They're actually surprisingly good data, especially for precipitation. But after the United States purchased Alaska, we kind of went into the climate dark ages. The Russians left. As many of you know, the U.S. rapidly lost interest in Alaska after 1867. And except for a very few special observations, for instance, at the town that would become known as Barrow during the first international polar year in the early 1880s, there are very few weather observations in Alaska from 1867 until the early 1890s, when interest in Alaska in the lower 40, was what, the lower 45 then? Started to increase. So the Weather Bureau out of Seattle and San Francisco started to send weather equipment to interested people, and this is the cooperative observers in the 1890s, and that continued through the Gold Rush era. The first paid Weather Bureau staff arrived in Juneau in 1917. That was the house that they soon moved into. And during this time, increased this cooperative network. Cooperative observers are people like John Borg that do this because they're interested. And then also established what were called second-order stations. You can think of those as contract observers. They got some additional equipment, they got some training, they got a small amount of money. And a lot of that was actually done in support of the growing aviation industry. In the 1920s, the Weather Bureau itself started to expand, opening offices in several locations. But then the Great Depression came, and there was actually quite a contraction in the weather observation network. Then, of course, we got to World War II, dramatic expansion almost overnight, and that sets the stage for our modern weather and climate network in Alaska. So here's what this looks like in map form. So Fairbanks first observations in 1904, Eagle and Tanana in 1901. The earliest dates are, of course, in southeast, where the early activity in Alaska was. You can see like Bethel, Utqiagvik in the 1920s. That was part of that second order expansion. Nome, Gold Rush, 1906. You can see the ones in red here, this is when the data starts, but there's significant either breaks or station moves that make the data less than as clean as we would like. The ones in black are pretty solid since those dates there. So you can see that we've got a fair number of sites now with around a century of observations. Notice, though, in the now population center of Alaska, we have surprisingly poor climate records. Anchorage, of course, Fairbanks was in a well-established town by the time Anchorage was even born, and because of Cook Inlet, even small station moves make a big difference. So we don't have as good a climate record in South Central as we like. For our part of the world, though, we have about as good as anywhere in the state. Some of you will recognize this. This is the ag farm now at UAF, and we just nominated this site as a World Meteorological Centennial Observing Site. It's the only one in Alaska. This picture is undated, but probably from the 1920s, and I've circled the little weather instrument shelter right there. And in fact, the observation has been within about 200 yards of where it's at now since July 1911. Now, the observations are not perfect. There's a few breaks, but this is actually by far the longest nearly unbroken, unmoved site in the state of Alaska. So we're really lucky to have that here. For Fairbanks and the Weather Bureau, a guy named Howard Thompson was dispatched from Juneau in the spring of 1929. He showed up in Fairbanks, rented some office space in the Horseshoe Building on First Avenue. His weather equipment arrived during that summer and fall, and he was good to go by that November. Moved into the then new federal building. Actually, before it was formally opened, moved in 1933. Stayed there till the war years, briefly out at Ladd Field, then the Weather Bureau at Weeks Field, which of course we're practically on, right? Arctic Bowl was a hangar from Weeks Field. And then out to the International Airport in 1951, where it's at yet today. Now, these are where the observations are. Of course, at some point here in the 1970s, the forecast office was separated from the observation site. Nobody cares where the forecast office is. We only care where the obs are from. So here I put them on a map for you, and you can see right there is downtown. Right there is about where we are. 1911 to 29, the ag farm is the only weather observation in the Fairbanks area. All of these are basically floodplain observation sites except the farm. It's about, 70 feet above the Chena River. So it can be important, especially for temperatures in the wintertime. So this isn't the perfect record for the official Fairbanks records. It's moved around a lot, and we do have this elevation change of possibly significant, but it's what we got, right? Thought you might be interested in this. This is the very first observation, weather and climate observation, here on September the 4th, 1904. And some of you will recognize the person that signed this form, the Reverend Hudson Stuck, very first weather observer in Fairbanks. And so we've gone through lots of changes during the last 100 and 15 years. And here's the current weather observation. This person's name is ASOS. The Automated Surface Observation System. This is currently, right, this platform is off the south end of the runway. If you're on the right side of the aircraft, landing, coming in from the west, you can see it just before the wheels touch down off on the right-hand side. It's inside the fence there. So it's not too far from the Tanana River, so a pretty cold place. So I've just kind of summarized some of the things I've just touched on here. So even for places like the ag farm, but everywhere that we have century scale records, there's both type and protocol changes. So that could be from a cooperative station to the Weather Bureau or the CAA taking over, CAA being the forerunner of the FAA. Location changes, of course. Instrumentation changes. Nobody in the United States is using the same kind of equipment to do weather observations that they were 100 years ago. And that's probably a good thing. Electronic thermometers started making their appearance in the 1960s and are now virtually universal. Manual precipitation is still done, although increasingly automated. There's oddball things like time zone changes can have an effect. The 1983 time zone change in Alaska, probably not a big deal for Fairbanks. It was only 1 hour. In the western part of the state, though, Kotzebue, Nome, Bethel, that were on bearing time, has a 2-hour change. So could be important during World War II. There was wartime. And then for the cooperative sites, these days generally observe daylight time, so that can be a confound too. But not all these changes are equally meaningful. Some, like at least the floodplain moves of Fairbanks, probably aren't a big deal for temperatures, but of course even small elevation changes can be important. Okay, so now the part you've all been waiting for. Graphs, data, enough of that history crap. Okay, so since we're talking about observations moving around, and it's winter, and it's Fairbanks, so let's talk about low temperature. So this is a plot every year since the winter of 1905-06, and each dot is just the lowest temperature recorded that winter. And so what I put on here, the bars, are those different observation sites that we just looked at. So back here in the Hudson-Stuck era, when the observations were at the Episcopal Church, you can see the blue line here was the average low temperature during those years, and you can see it's much colder than any of the other times. Now, was it just a cold few years? Observation, of course, practically on the banks of the Chena River. Pretty cold place. And you can see immediately when the observations moved out to the ag farm, considerably warmer. Now, is that a factor of just the elevation difference? Were those years warmer? Probably some of both, right? 1930 to 1943, observation is back on Cushman Street, Federal Building, and it's definitely colder than the era of the ag farm. Brief time at Weeks Field. This is probably mostly a function of warm winters that this is higher. And then the last line there, last two lines are out at the airport, and I broke these up here, not based on any weather factor, but pipeline. So is this just a function of the pipeline era and then the growing urban sprawl of Fairbanks with these warmer temperatures here compared to the 1950s to the early 70s? Is it what weather and climate factors are going on in there as well? All of these things are part of the mix, right? We're not going to find, there's not going to be one cause, right? You got all the interplay of changing urbanization. We got different weather patterns, different instrumentation, different practices. So luckily for Fairbanks, we can control for some of that, right? We're blessed to have that century of observations at the ag farm where the observation's been almost in exactly the same site. And lo and behold, this works out very well. So from the same site, out at the Agricultural Experiment Station, 1911-12 up through this winter. It's, of course, we could still be lower than this, but we're not out of time, but we're almost out of time. But basically, we got some cold, low temperatures, we got some not so cold, low temperatures, but there's obviously not a lot of trend. Starting in the 1980s, notice the ag farm has not been below 55 below since the 1970s. We know that this is not caused by a difference in location. I would argue that what we're seeing here is the growing urban effect. There's also some weather effect here, but especially the lack of really cold here is probably reflecting urbanization. These really warm winter lows are really interesting. These are probably not the result of growing urbanization. The growing urbanization mostly comes into play, not entirely, but mostly comes into play with ice fog. Well, when's the last time we had any good ice fog? Been a while. So that's probably not this. This is probably another signal. Okay, so population in Fairbanks has grown a lot in the last 100 years, especially in the last 50 years. So let's go out to Tanana. Tanana has as long a record, weather and climate, as Fairbanks. It's not as clean. There's a few breaks. Population, though, is almost exactly the same now as it was 100 years ago. And so here, instead of looking at low temperatures, I thought, well, let's look at something that's not likely to be influenced by ice fog or small changes in elevation. So this is, each dot is a plot of how many days that winter was the high of 20 below or lower. So that's not an extreme event by interior standards. And you can see here, the blue line here kind of represents the upper bound of typical. For those that care, this is the 75th percentile line. And the best fit here is about, a little over 20 days up into the 1970s, and it's come crashing down since then. However, if we ask what's kind of the bottom end of the low range, that has not changed in the last 100 years, around 6. So here we've controlled for both population and we picked a not so extreme value. And again, we see pretty dramatic decrease in the number of cold days at Tanana. Okay, feel free to throw your tomatoes. Okay, so I thought this would be fun. So the underlying map here by Dr. Brian Brettschneider at UAF, and this is the lowest temperature for whatever the period of record that we have for various stations. There's the 66 below in Fairbanks in January 1934. There's your 80 below, Prospect Creek, 1971, 81 below at Snag, Yukon, 47, 75 at Tanacross the same day. Okay, who wants to beat this? Okay, so I put some off here to the side just because these numbers were getting crowded. There's no reasonable chance that if we had a long time series from chicken that the low would only be 72 below. 40-mile country is incredibly cold in the winter. Deep valleys, high elevation. We've only got about 25 years of data from chicken, and none of them are during the epic cold snaps. So if anybody here ever live in chicken in the winter? Well, if you do, it's not hard to find people that say, oh, it's 85 below, it's 90 below. All right, well, is that just a tail grows taller thing? Well, it might be some of that, but it might be true too. You can see the coastal effect very nicely here with, of course, extremes are not nearly as high or as low on the coast. The interior is the land of 60s and 70s below for sure. One low, all-time record low at Sitka. Okay, so temperatures are one thing. How about snowfall? Well, snowfall actually shows no trend at all over the last 80 years in Fairbanks. You can see this is just a plot of the seasonal total, and there's some big spikes here. The 1937, some here in the 60s, the several big years there in the 90s. Last year was pretty respectable, but overall there's no trend. There's a few low years, but snowfall represents one of those quantities. When you plot how these fall, doesn't fall into that typical bell-shaped curve, or the stereotypical bell-shaped curve. You can see it's got a long right tail. There's a few ways to get a whole lot of snow in Fairbanks in the wintertime. It's pretty tough to get less than about 25 inches. So what can we do with this kind of high-quality snowfall data, the 85 years worth? Well, one of the things we can do is ask, how much could it snow? So you maybe have seen this kind of thing or heard this kind of thing with heavy rainfalls during Hurricane Harvey this past summer. You may have seen, estimate, 1 in 1,000 year rainfall kind of thing. Well, we can do the same thing with snow, right? So this is just a plot. So using that snowfall data, so this is the return period down here on the horizontal axis, and this is just snowfall in inches here. And right now, our maximum 24-hour snowfall in Fairbanks is around 20 inches, and that comes out just about to be a 1 in 100 year event. On the other hand, the about 73 inches of snow that fell in 31 days there in that terrible February of 1937, that has a return period of almost 150 years. So this is the kind of thing we can do with these high quality data sets. The blue line here, 2-week snowfall, 1 in 200 years would give us about 68 inches of snow in 2 weeks. That'd be a lot of snow. But that's that's certainly within the realm of plausibility. If this were to happen sometime soon, this is the kind of information that I would be using when I'm talking to media about, well, we broke the record by so much. How unusual is this? This is the kind of information that I'd be using. I hate freezing rain. We got a lot of questions about freezing. We get a lot of questions about freezing rain because it's so impactful. Unlike the lower 48, of course, when it rains here in November so significantly, that means secondary roads are going to be icy until breakup. Bad news for us. So I trolled back through the historical data since 1916, and I was looking for big rain events, more than 1/10 of an inch. I picked this out not because that's impactful nowadays. Nowadays, the smallest amount of rain is very impactful, but I picked this so that I could go back through that daily data and have a reasonable estimate. And the results were very surprising to some people. For those of you that were here in the 1960s, pre-pipeline, may remember this. There's a big spike of freezing rain events in the 1960s when many of us in this room, or at least some of us in this room, showed up in Alaska in the 80s or early 90s. This is a drought of freezing rain events. There weren't very many of these big events. Neither of these quite compares to the 1930s. Late 20s and 30s, when there were multiple rain events during the winter. Winter here defined as November through March. Really quite remarkable. If this were to happen today, I mean, we'd be brought to a standstill. But as it is, the main thing that we're seeing now, it looks like, is we're on a long streak here. The green line is just the events per decade, kind of people's working memory. And looks like we're getting to be about as long as that 1920s streak. So very interesting. Did I mention I hate freezing rain? Just wanted to be sure. Okay, so now that you're chilled, thought I'd bring up a couple of other examples looking ahead. So river breakup, which I know many of you will take an interest in. little bit about growing season, and then I thought I'd finish up with couple slides on what's going on at Utqiagvik. It's been in the news. I figured some of you would ask, so threw in a slide or two. Okay, so Tanana River at Nenana. Many of you have probably made this graph yourself. And if you haven't, you've surely seen it. This is the Rick Thoman version. So, and the green band here is kind of the near normal. Anything above the green band would be later than normal. Below the green band, earlier than normal. And as we all know, breakup is very strongly concentrated now, significantly earlier than it was in the first two-thirds of the 20th century, to the point where last year's May 1st breakup was very close to significantly later than normal in our era, but would have been significantly earlier than normal 60 years ago. So, and of course, Tanana Nenana breakup is the climatologist's dream data set because it's been made in the same place, in the same funky way for 100 years. The population of Nenana hasn't changed very much. The Tanana River is one channel there. It's the ideal data set. But of course, it's ideal, but it's still not good enough, right? I didn't know this till I started researching this. Breakup on the Tanana Nenana was not the first breakup betting game in Alaska. That was it for Fairbanks, the Chinook Fairbanks. And it turns out we've got very good breakup dates on the Chinook River since 1903. So this is just the winter after E.T. Barnett got booted off the Lavelle Young. So what I did here, and of course, the Chinook River of the early 20th century is not the same Chinook River that we know today. Prior to the diking at Moose Creek that occurred in the early 1940s, the Chinook River was regularly referred to as Chena Slough, and it carried most of the year, it was mostly carrying Tanana River water. So it carried a lot more water than it does now. So we've got about 25 years of overlap for breakup dates on the Chinook Fairbanks before the dike was built, and at the same time we have the breakup dates for the Tanana Nenana. So I just correlated those dates and then just used those as a prediction for, okay, well, given this correlation prior to the mid-1940s, what would have breakup dates been on the Tanana at Nenana? And the dots are the best guess. The little lines there, that's the kind of the 80% chance that the date would fall somewhere on those lines. And in some ways, this is completely uninteresting, right? It looks exactly like when we have information. But what it does, it helps reinforce the idea there's nothing different going on prior to 1917, back to 1903. We see exactly the same thing with the breakup information on the Yukon from Dawson, where breakup dates from 1898 up through the middle part, past the middle part of the 20th century were random, scattered, didn't show much trend, and then in recent decades are getting earlier. All right, some of you want to plant your garden. Big hot topic every spring and fall is growing season. So again, we're going to use our ag farm, our not perfect, but our century-long observations from the unmoved site at the ag farm. And the green bars this is just this is the start of the growing season. This is the end of the growing season. Growing season here just defined as the last and first occurrence of a temperature of 32 degrees. And so this is really interesting, I think. So the best fit line here in the fall is just this steady increase. We've increased there, from August 22nd to September 5th is the best fit here for the median breakup date. Notice though on the last freeze in the spring, doesn't show that nice steady trend, but rather it's flat here up until the late 1970s, and then shows a fairly substantial decline since then. So that's what we've gained 2 weeks of freeze-free in the median date here in the springtime. So overall, we've gained about a month here at the ag farm for the duration of days with temperature remaining above 32. So I'll let you in on a little secret here, paper I'm working on right now. So we're going to do this kind of analysis for the whole state. This one go from 1952 to through this past fall. And curiously, all the places where the growing season is increasing are in red, and there's some places where it's actually decreasing. I picked 1952 because all of these sites have had observations at the same place since then. The 10 is actually the Fairbanks Airport there. But it's kind of interesting here. So both Bettles and Fort Greely Airport, the growing season has decreased slightly. It's not statistically significant. That is to say, could just as well be a random chance that it's shorter. This area in southwest Alaska is interesting too, only because it looks spatially coherent there. So, but really some really quite dramatic changes over mainland Alaska. 30 days at Eagle, 32 days at Kotzebue with a pretty strong marine component that's probably reflecting changes in sea ice and ocean temperatures in the fall. Okay, last little bit. And I wasn't going to put this in, but I thought that people would ask because it's kind of different. So you probably have heard in the news this fall that temperatures at Utqiagvik have increased so much that some algorithms run by NOAA have spit out the data as being, they didn't think it was realistic, a realistic climate change. Now, let me post this by saying everyone knows the data's fine. It's the algorithms that we're having a problem. And we'll see this right here. So this is the average temperature for the month of October since 1920. And you can see the red dots were Octobers that were warmer than the long-term average, significantly warmer. The black dots are near normal. The blue dots are significantly below normal. Okay, so exactly nothing interesting here, right? So you got some warm Octobers, you got some cold Octobers. Yeah, you know, if you look here, so there's a bunch of warm Octobers back here in the 1930s and 40s. There's kind of a dearth of warm Octobers in the 1960s, but all in all, doesn't look very exciting. So that's up through 2001. Well, what's happened since then? Ta-da! Congratulations, ladies and gentlemen. You've just witnessed the birth of a new climate. So this, of course, is entirely driven by the collapse of autumn sea ice. So not only since 2001 is every October significantly warmer than normal, there's been a complete collapse of the year-to-year variability that we had back here. Now, I say birth of a new climate. It's not a new climate in the whole world. But Barrow's gone from kind of a mixed Arctic marine and Arctic continental, depending on the ice that October, to entirely an Arctic marine climate. Stunning. And this is the kind of change that was throwing off NOAA's QC algorithm. And that's because that algorithm was tuned to look for changes that would be typical at mid-latitudes. Well, the Arctic is warming much faster than the rest of the world, and places like Utqiagvik, places like Svalbard that have the potential for a very strong marine influence, those changes in ice have a dramatic effect. So, last wrap-up slide, another photo inadvertently containing a weather station. Since the 1890s, this talk is the work of thousands of people. We got a good number of sites now with a century or more of observations, and I hope I've given you a taste of what we can do when we have high quality information over longer than a human lifetime. It's not just about climate change, that's part of it, but there's many other things that we can do with that information that can help as we build our state and our community for the future. So with that, I would like to, again, thanks Fritz and Sue and Ned Roselle who reviewed this, and thanks for coming.